Welcome back. We're continuing to look at multi-step equations. So let's go ahead and dive into another one. Let's say we have 3 times x plus 1 divided by 8 equals 1/2. Now this may look familiar. In our previous video we had a very similar exercise, only without the parentheses. And we're going to see that just inserting some parentheses into our problem actually will drastically change it, and we'll see that in a second. But we'll start out by handling it in a very similar way. We're going to multiply both sides by 8. This is going to get rid of the denominator right here, because this 8 is going to cancel with this 8. The first thing we want to do is get rid of this fraction bar, since our variable is buried inside the numerator. So what this is going to do is leave us with 3 times x plus 1. And we know how to work with this. So we got rid of the fraction bar, which is a good thing. And on the other side, we have 1/2 times 8, which is 8 over 2, which is just 4. Okay? Now we need to remove the x outside of these parentheses. We always want to, our main goal is to extract our variable out of any fraction bars or parentheses or wherever it's buried in, and we want to get our variable x on one side and all the rest of this junk on the other side. So our next step is going to be to distribute this 3 into the expression. So let's go ahead and multiply this through. We have 3x plus 3 times 1 is 3. And we still have our 4 on the other side. All right. Now we can get rid of this 3, move it to the other side by subtracting both sides by 3. That's going to cancel the positive 3 and the negative 3. It's going to leave us with 3x, and 4 minus 3 is 1. And now we have a variable multiplied by a whole number, so we simply just divide by the coefficient, and that'll cancel the coefficient of the variable out. Do the same thing on the other side. These 3 cancels. We have an x equal 1 over 3, and that's our answer. So you can see just inserting these parentheses right here, using the same numbers and variable placement, we actually get a completely different answer. I believe in the previous exercise we have x equals 1. So we want to be careful just noticing any slight changes. We want to pay attention to detail, because any slight sign or parentheses or anything will actually throw our answer off. So we always want to pay attention to detail when we're working through equations. Let's go ahead and look at another one. Let's say we have 4y plus 1 divided by 4 minus 6y equals 3. Okay. Once again, we have a numerator buried inside the numerator. We have a variable buried inside the numerator of the fraction, and we also have it appearing in another place. So while we could approach this example in the same way by multiplying through by 4, we would actually have to multiply 3 terms by 4. This term, and this term. So instead of doing all that, let's do something else. Let's go ahead and split this fraction up into 2 fractions. We have 2 terms here. We have a 4y and a 1, and they're over a common denominator. We know how to take 2 rational numbers that have the same denominator and combine them like this. So we can actually work backwards and split them apart. And we can do it like this. We can take this and say, well, this is one fraction, this 4y over 4. So we can write 4y over 4. And we can write plus and make this another fraction, this 1 over 4, which is 1/4. And then we still have our minus 6y and our 3 on the other side. Now we can go ahead and add these together and see if we get back to this, just to make sure that this is indeed true. Because if we add 4y plus 1, then we get 4y plus 1, and we have a common denominator. So we can just combine these. So we can split these up if we want to. And in this case, it'll actually make it easier for us. So very useful technique if we can remember this one. So these 4's actually go ahead and cancel. So we're only left with y plus 1 over 4 minus 6y equals 3. Okay, we just changed the 4 over 4 into a 1. Nothing fancy there, no magic. So now we can combine the y's. We have plus 1y and a minus 6y gives us a minus 5y. Plus 1 over 4 equals 3. Let's go ahead and subtract 1/4 from both sides. And we're continuing to move things over to the right now. That cancels. So we have our minus 5y equals, and we're going to have 3 minus 1 over 4. Let's go ahead and convert 3 into a rational number with a denominator of 4. So we're going to have 12 over 4, which is the same as 3, minus our 1/4. We're just getting it positioned to where we can actually subtract it easily. So we have our minus 5y equals 12 minus 1 is 11, so 11 over 4. And now we just have one more step. We have a coefficient out in front of the variable being multiplied together. So we want to divide by the negative 5 so we can get a positive y. We're wanting to get a positive y. We're dividing by minus 5 over here as well. These cancel. So we have y equals, well, we can write this as minus 5 over 1. And when we're dividing by a rational number, we rewrite the first one, and we don't ask why, but we flip the second and multiply. So we multiply by a minus. Instead of a 5 over 1, it's a 1 over 5. And this gives us, we have a positive and a negative, which gives us a negative. 11 times 1 is 1, and 4 times 5 is 20. So we have a negative 11 over 20. Okay, so there's always more than one way to, usually more than one way to go about a problem, and sometimes splitting fractions up is a little easier. Sometimes when I say we want to simplify a problem, it doesn't make it shorter, it just makes it easier to deal with. So keep that in mind because that's a very useful technique. Let's go ahead and do another one. Let's say we have 9z minus the expression 3z minus 4. And that's going to equal a minus z over 3. Okay, so we have z's all over the place, and actually on both sides. So let's go ahead and start breaking this apart. Let's go ahead and distribute this minus sign into this expression here. So we have our 9z minus 3z plus, watch our signs here, a minus and a minus gives us a plus 4. And we have our minus z over 3. And we can go to the next step. Let's see, we can go ahead and combine these two right here. 9z minus 3z is 6z plus 4 equal, and let's go ahead and break this fraction apart. This is actually a minus 1 over 3 times z. And we saw that in a previous exercise that minus 1 over 3 times z is the same as minus z over 3. Because there's an understood 1 in front of our variable. Just little aspects like that. The little things actually make a big difference in the end because it makes things much easier. Let's go ahead and move our variables to the left and everything else on the right. I like having the variables that we're solving for on the left because it makes things flow a lot simpler for me. So let's go ahead and add a 1/3 z to each side. Plus 1/3 z. This is going to cancel over here, and let's go ahead and let's translate this 6 into a fraction with a denominator of 3. So this 6 is going to be an 18 over 3z. 18 over 3 is the same thing as 6. And then we have plus 1 over 3z plus 4 equals 0. Okay, so now we have common denominators here. We can combine these terms. 18 plus 1 is 19 over 3z. You just combine these. We have plus 4 equals 0. Now we can move our 4 over by subtracting 4 from both sides. This cancels, so we have our 19 over 3z equals a minus 4. And we have, let's go switch colors, we have one step left. We multiply by the reciprocal, because we have our variable multiplied by a rational number. So let's multiply both sides by 3 over 19. 19 over 3z. And on the other side, we have our minus 4 times the same reciprocal, 3 over 19, doing the same thing to both sides. Doesn't change our equation. This cancels with this. So we have z left on the left. Minus 4 times 3 is a minus 12 over 19. And there you go. Okay, let's go ahead and review these a few times. We're going over a few different techniques, a few different approaches that we can take to solving multi-step equations. And always remember that whenever we find the solution to our variable, we can always plug back into our original equation to make sure that indeed we were accurate and we didn't miss anything and we got the correct answer. So I'll leave you to check these, and I'll see you in the next video.